Well, hello everybody. Now coming straight to the point, we have to see that what is the actual difference between the centripetal force and the centrifugal force. Okay, fine. Suppose if I am standing out here, right, and I will be having one string in my hand, which is being tied to a mass m, right? This mass m is being rotated in the vertical direction, in the circular vertical direction, right? Okay. What we see that if you draw the free body diagram out here, and I'm standing out here, right? I will say that there is one tension acting in the inward direction T, right? And the mass or the weight of the mass Bob is acting in the downward direction, say mg, right? Okay. And the T minus mg, that will be equal to mv square by r. That will give the expression for, some say it will be centripetal force. Someone say it might be centrifugal force. Okay, then what? Then where does the difference lie? Then where does the difference lie? Difference lies in the fact that if I am standing in the frame, right? If I am standing in the non-inertial frame, means at the center of the frame, right? Which is being accelerated. Yeah, the frame is being accelerated, right? And I am standing inside it. So for me, it will be like a centrifugal force. Centrifugal force is actually what? It is acting at the source of the centripetal force. Yes, it is acting at the source of centripetal force, right? Okay, fine. So means what is the source of the centripetal force? The centripetal force is actually that you can say that Bob, the mass on me, myself, on which the centrifugal force is acting in the outward direction, right? Right. But someone who is standing outside, means like some of my friend who will be standing and seeing me rotating a mass with a string in the circular vertical motion. Okay, so it will be coming out here, then here also. Okay, fine, right? And he is standing out here, and if he has to draw the free body diagram of it one, so he will say that this one, if we take it at an instant like this is the mg, this is the t, right? And this t minus mg will be given as mv square by r, which is actually the centripetal force. Okay, so for him it will be a centripetal force, and for me standing inside the frame it will be the centrifugal force. My friend is standing in the inertial frame. My friend is standing in the inertial frame. Okay, my friend is standing in the inertial frame, which is not moving, which is non-accelerating. Okay, non-accelerating. And me myself, means nickel is standing in the non-inertial frame. Okay, right? So for me it will be like the centrifugal force, which is a pseudo force. Okay, which is a pseudo force. Okay, right? And for him it will be the real force that is acting for him, right? If you will be drawing the free body diagram of it one, right? Okay, fine. Okay, this is what the basic difference between the centripetal and the centrifugal force, that from where you are observing the forces acting on a body moving in a circular motion. Okay, fine. Second thing is that we usually have one misconception that the centrifugal force is The reaction force is the reaction force of centripetal force. This is wrong. Okay, this is wrong. Second thing, second misconception too. Centrifugal force and centripetal force acts at the same time. Acts at the same time. So sometimes in haste, it is this fault is being made by the faculty also, that the centripetal and the centrifugal force are acting at the same time. It's wrong. Only one force is acting, right? If you are standing inside the frame, for you it will be the centrifugal force. If I am standing outside the frame, for me it will be a centripetal force. Okay. So I hope that you might have uh, seen that how the centripetal and the centrifugal force are being differentiated on the basis of the frame of references. Okay, that's all for my video. Thank you for watching it.